Hello! I'm super excited to start the course with you, but before we do, we need to see where we're starting and where we're ending up so we have a clear path to success. So let's see what this course will look like for you. First, we start off with Deno Foundations. Just basic fundamentals, how Deno is built, what the internal architecture is, how it works, so that we truly understand this JavaScript runtime. This is going to build the foundation for the rest of the course. We then dive into comparing Deno with Node. You see, Deno was created by the same creator of Node. So in order to truly understand Deno, you need to understand Node, some of its shortcomings, and how Deno tries to improve it. This is going to be a very interesting section. Next, we start learning about modules and tooling and discover the unique ways that Deno handles these things. This is where we get to really discover the power of Deno and how we can use Deno to build some large applications. Then we start getting into some really fun scripting when it comes to Deno. With Deno, we can do a lot of things now. And one of the projects we're going to be working on is working with real-life planetary data from satellites and trying to discover planets around the universe that might have life. That's right, we're gonna read data, reading files, and try to discover useful information using Deno. This is gonna be a really fun one, and I'm really excited about this section. Next, we start talking about backends and APIs. At the end of the day, Deno will most likely be heavily used for backend servers and building APIs. So we're going to learn about how to build these systems. And in here, we're going to do a fun project using SpaceX data to analyze their launches and their launch schedules. And once we have these foundations laid out, once we understand the internals of Deno, how Deno works, what the best practices are, this is the fun part. We build a massive NASA project. We're going to build a NASA mission control dashboard where we can schedule launches, see the missions, all powered by Deno. But most importantly, along the way, we're going to cover things like performance, testing, security, debugging, using Docker to deploy to production on AWS. All things that as backend developers, we need to know. We're going to use modern practices to build actual secure applications that you can trust. By the end of this project, you'll have a great looking portfolio project, but more importantly, you'll have the ability to create your own projects and feel comfortable that you are deploying something using modern best practices. Along the way, because everybody has different level of experiences, we also include bonus sections on JavaScript and TypeScript so that when we build our projects, we really know how things work. We know how to use TypeScript in our project and overall have a modern tech stack using Deno to build real-life applications. I promise you, we'll make it fun along the way, and by the end of it all, this is all going to fit in together and make sense to make you truly understand Deno and its power. We're going to take you from zero to mastery. Oh, and I almost forgot the best part. The best part is right here. Our online private community of over 130,000 programmers. We have people chatting here every day, going through the course, helping each other out, solving problems together, doing coding challenges, and just talking about the latest and greatest in programming in general. This is an optional resource for you to use so you can have back and forth conversations with other students and your instructors like myself so you feel like you're part of a classroom. I'm on there chatting every day with students. But you know what? Enough talk. I'm getting excited. I feel like you are too, otherwise you wouldn't be here. So let's get started and let's start diving into the world of Deno. Welcome to Deno Park. Guess what, everybody? Our new friend, Deno, right here, Deno's born. But what is Deno? I mean, yes, Deno is a cute little dinosaur right here, but Deno is also a very new, exciting technology. It's a JavaScript runtime, which we're going to talk about. But what does it all mean? Why should we be excited about Deno, and why should we even care? Well, if we go to the Deno website, we get a bunch of buzzwords. Deno is a simple, modern, and secure runtime for JavaScript and TypeScript that uses V8 and is built in Rust, and a bunch of features. Now, if you have a bit of experience or you're a senior engineer, you might know what those words mean. If not, don't worry, we're going to dive really deep into those topics and actually understand the internals of Deno. What it is, what it does, why is it so different from Node, and why you should keep an eye on it, because the future might have a lot of Deno developers. But if this were caught your eye, secure runtime for JavaScript, then that's a good sign. You're taking this course because you probably already know about Node. Node is a JavaScript runtime, just like Deno is. So why do we need another JavaScript runtime, a place where we can run our JavaScript code? That's actually a good question, because why do we need Deno? We have so many programming languages. I mean, we have our Python, we have our C++, we even have PHP, and we also have Node.js. All of these are ways to write programs, right? And at the end of the day, programs are just instructions that we can write so that computers do tasks for us. And all of these languages are different ways that we can communicate with a machine or a computer, but at the end of the day, they're just different syntax. Just like we have human languages, we have languages to communicate with computers, but at the end of the day, all of them do the same thing. Hey, machine, do this for me. So why do we need a new thing? Well, we have one guy to blame for this, and his name is Ryan Dahl, right here. And Ryan Dahl is an interesting character because he's also the one that created Node.js. Now, back in 2009, which by now seems like a long time ago, Ryan Dahl created Node.js and opened up the world of JavaScript. What do I mean? Well, initially JavaScript would just be meant for the browsers. If you used Chrome, if you used Firefox, if you used Safari, these browsers allowed you to run JavaScript code for what we call the client-side applications or websites. So I can open up the developer tools, go to console, and write JavaScript in here, like console.log. Hello. And initially, that was it. We were able to write JavaScript on these browsers. And then we had other languages to do other things. If we ever wanted to do something outside of a browser, well, we can use Python. We can use C++ to build desktop apps. But Ryan thought, wouldn't it be nice if we can use JavaScript outside of the browser as well? Maybe even build servers with JavaScript. And he created Node.js. So if we already have Node.js, why did he create Deno? And this is a topic that we're going to explore throughout the course, because in order to truly understand Deno, we have to understand what the differences are from Node, but also the reasoning behind why Ryan decided to create something that essentially does the same thing as Node, something more modern. But to just get you excited, because I certainly am excited about Deno, otherwise, well, I wouldn't be creating this course. Deno has a few things going for it. Now, a lot of these things we're going to go deeper into the course, so don't stress out too much if this is new to you. We're really going to know how Deno works internally. But the big thing is that unlike a lot of technologies, a lot of libraries, frameworks, tools that we use as developers, I think Deno is going to have a long lifespan. And it's partly because of this. You see, it's written in Rust, a programming language that is heavily invested by Mozilla. And Mozilla works on the Firefox browser. It has first-class TypeScript support. So you can write TypeScript out of the box with Deno, which TypeScript is supported by Microsoft. It's created by Microsoft. And then it uses something called the V8 engine, which Node does as well, to actually read your JavaScript. And the V8 engine is what's running the Chrome browser. It's why I was able to write JavaScript in my browser, on my Chrome browser. But because of this, this means that Deno is built on some really reliable technologies. Technologies that are probably going to be sticking around for a long time because they have these heavy backers. But how can we have Deno using all of these technologies? And the first thing I want to talk about is the V8 engine and how Deno is built on top of this engine. So Deno is a JavaScript runtime and a TypeScript runtime. And if we go to the Node website, Node is a JavaScript runtime built on the Chrome V8 JavaScript engine. So they're both built on this engine, V8 engine. Sounds pretty cool, but what is it? Well, a JavaScript engine does exactly that. It moves our JavaScript that we write ourselves as programmers and spits out instructions for the machine that it's running on. So for example, for Google Chrome that uses the V8 JavaScript engine, when it receives a JavaScript file, it's going to say, oh, I understand JavaScript, and this is what the programmer is trying to tell us. So it receives the JavaScript file or the JavaScript code, and then it gives instructions to the browser to say, hey, this person said to, I don't know, create a drop-down menu or do something or submit a form or log in a user. The V8 engine is what understands JavaScript, and it turns our JavaScript code into what we call machine code, ones and zeros, to give instructions to the computer. And at the end of the day, that's all programming is, right? We write in different programming languages, but all of them get compiled down to ones and zeros because machines, computers, only understand ones and zeros. And people create programming languages as a way for us to easily write code without having to write ones and zeros. And they build these engines that are able to translate from a human readable programming language to something that, well, is just ones and zeros to tell a computer what to do. So why do we need the V8 engine? Well, we need the V8 engine because at the end of the day, Deno is essentially a shell around the Google V8 engine so that we're able to write JavaScript code, and this V8 engine takes that code and gives instruction to the machine. Now, Node is also this shell around the V8 engine. Because the V8 engine is developed by Google, it's really, really good, it's performant, it's fast, it's constantly being updated. They leverage this constantly updating engine to read our JavaScript files. But on top of that, it's a runtime. So as long as we include Deno or Node.js anywhere on a computer, we can run JavaScript, but it can also give us extra tools that maybe the V8 engine doesn't give us. Maybe things outside of JavaScript. For example, we can use TypeScript. Deno compiles our TypeScript, changes it to JavaScript, and then feeds it to the JavaScript V8 engine. Now, this is a simplified version, but just by looking at this, we should understand that what we need to do next is to, well, install this runtime so we can start writing Deno code. Just like we install Node on a machine that we want to run JavaScript, we have to install Deno to be able to run JavaScript. That's why we need a runtime. If I don't have these two things and I write JavaScript code, let's say on a text file on my desktop, who's going to run it? My computer doesn't know what JavaScript is. They're going to say, well, I have no idea what you're talking about, Andre. So we need to install Deno. Now, you might be wondering, why can I run JavaScript on the browser then? I mean, I can do simple JavaScript stuff here. I can say alert, hi. I'm able to write JavaScript here, but I didn't install anything. And remember what I said before, JavaScript initially was meant for the browsers. browsers, when you install Google Chrome, install Safari, Firefox, the Edge browser, all of these come with the V8 engine built in. You download them onto your computer, and when you run this Chrome browser, the JavaScript engine is running behind. But if we ever want to run JavaScript outside the browser, like we're going to, well, that's when we need Deno or Node. And by the way, this is what you do with programming languages. For example, if you wanted to write Python, which is another programming language, well, you need to download Python because you need a place that understands Python and is able to run this Python code. So you'd go to downloads and you'd get the latest version of Python that comes with things like interpreters to be able to read your code. All right, enough chatter. I think it's time for us to download Deno and write our first Deno application. All right, we're a few videos in. We're still scratching the surface. We still don't really understand why we need Deno. But we do know one thing for now. We know that it's a runtime. It allows us to run JavaScript and TypeScript. We'll talk about that. And it uses V8 engine for Deno to be able to understand JavaScript and give instructions to the computer. Now there's a whole bunch more. Don't worry, we'll get there. But the first thing I want to do, because hearing me talk all the time might not be that exciting, shocker, I know. So let's actually write our first Deno program and then work backwards and see what's running it, what's behind it, what's the architecture of it, and really dive deep as to what Deno is doing. So, as with anything, we go to their official website, deno.land, and we go on install. And they actually have really good documentation on how to install Deno. So it's very, very simple to use. If you're on Mac or Linux, you have a bunch of options. If you're on Windows, you have a bunch of options. I recommend one of these two options. So if you're on Windows, just open up PowerShell on your computer and type in this command. And if you're on Mac or Linux, just copy this command and it would install Deno for you. Now, if there's any issues whatsoever, you can go to see Deno install for more installation options to make sure that you can, well, run Deno. Because at the end of the day, if you can't run Deno, then this course isn't going to be very fun for you. Now, I'm going to copy this bit of line because I'm on a Mac. And I'm going to open up my terminal. So again, if you're on Windows, you might want to use PowerShell. If you're on Mac or Linux, your terminal is all you need. So in here, I'm going to copy and paste the code and hit enter. All right, there we go. We've installed Deno. That's awesome. And it says Deno was installed successfully to this path over here. So if I actually go to my username .deno bin Deno, that's where it was installed. If you're on a Windows, then you'll probably have a different path, but you can take this and actually open up the folders and see that Deno installation there. So now, here is where Deno lives. For example, if I open this up in my folders, you see that I have .deno here. And in here, again, if we go into the bin folder, we have the Deno, what we call the executable. And an executable is simply that. It's a file that, just like on Windows, there's an .exe file. If I double click it, it's going to run it. So by double clicking this, it's going to run Deno. Check it out. Look at that. I now am running Deno. So right here, you see here that I'm no longer in my desktop. I'm in what I call a REPL. So now I can actually run JavaScript commands here. Console.log hi is going to return hi. Very, very cool. And I can also do this in my terminal. Again, if you're on Windows, the command might be different. But if I do open here, it will open up the Deno runtime. Awesome. So we have that installed. And you see here that we can even run the help command to get us started. So I can even just copy and paste this, and it'll give me all the information that I need about Deno. So these are the documentation. Look at that, a secure JavaScript and TypeScript runtime. To start the REPL, we run Deno. So now, by reading this documentation, I say, oh, okay, instead of me having to open up Deno executable every time, I can just run the Deno command because we've installed it. So if I go Deno, oh, not done, Deno, because we're not done with the video yet. It says unknown command Deno. All right, so we have Deno installed and we can start using Deno, right? Not really. And depending on the way that you installed Deno over here, you might come across this command, which is unknown command Deno. You can't run Deno. Even though we saw that we could open up the Deno executable file, double click it, and actually run Deno, when I run the actual Deno command in the terminal, it's not working. Now, the reason that is because, well, we need to adjust our path. If you remember, when we installed, you can see over here that it asks us to manually add the directory to our home bash profile or similar. Now, this bash profile is essentially your terminal shell. Well, right now, you can see here I'm using fish shell, but if you're using bash profile, you need to add these 2 lines in order to run Deno. So for example, I can even copy and paste this over here and hit enter. And now Deno works. There you go. Awesome. I can write my JavaScript code. But let me exit this by saying close. The problem is that anytime I open a new terminal, it will do the same thing. So if I open this up and do Deno now, it's going to say we don't know Deno. So we need to add it to our profile so that every time we open up the terminal, it knows where to look for the Deno command in that folder where our Deno executable is. So what they're saying is to add this to your profile. In my case, I use fish. So what I'm going to do is say nano and go to where my fish profile is, which is this file path. So now I'm going to just copy this, do nano, and go into my fish profile and just copy and paste this at the top. Again, at the end of the day, all it's doing is saying, this is where our Deno is installed, and our path is going to be where our Deno is installed, which we set over here, in the /bin folder. That's it. And this $path is just a Unix thing that allows the computer to know where to look for these commands when they're run, to check that they exist and then run those executable files. So I'm going to just exit out of here. And now if I run Deno, it works. If I open up a new window, let's make that a little bit bigger, and I run Deno, that works as well. But here's another problem. I'm going to open up another window. And this terminal, I know we have a lot of windows here. If I run Deno here, command not found. And that's because I'm running a different shell. So once again, I can say nano.bash profile. So remember, that's the other shell that we could use. So if I do .bash profile, I can add the same command again, the export here, save, and now if I do Deno, well, it doesn't work because I updated my bash profile, which is another shell. But as you can see here, I have it set up so that default shell is ZSH. So again, if you are running a different shell, you simply just say ZSH profile, edit. And look at that, we have a bunch of Stack Overflow answers, and look at that. So use this endpoint. Again, this is part of being a programmer, right? Figuring out these solutions and learning how to, well, even though it's the first step, install Deno. So now if I do this, I can copy and paste. And now I can run. Oh, I have to open up the new terminal just to refresh, and now I can run Deno, just like that. Now, this install process was a little bit much. It was a lot, but I wanted to show you how to debug it in case you encounter these errors. If you actually use different methods of installing, like Homebrew on Mac or Scoop on Windows, you might not have these issues, but I wanted to make sure that if that was the case, everybody can run Deno. Now that we have Deno, we should be able to write our first program. Don't worry, this was probably the hardest part. Once you have Deno running, everything else is going to be fun and easy. Now, if you're a Windows user, the installation process is also fairly easy. All you have to do, if we go to the Deno docs, is use the Windows PowerShell, or you have a couple of other options like using Scoop or Chocolatey. But for now, I'm just going to copy this and then open up PowerShell. So I'm going to open up Windows PowerShell. And I'm just going to copy and paste and install Deno this way. And there we go. We have Deno was installed successfully at this location. So again, you can see here that it's a .exe file, so that's an executable. So if I go to this folder and then double click the deno.exe, it will actually open up the Deno runtime for us. Or I can just do Deno, and look at that. Now we're in the Deno, what we call REPL. So I can start writing JavaScript code. There we go. You have Deno installed on your system. Once we have Deno installed, you might want to open up your favorite text editor. You can use whatever you want to write your code. The most popular one right now probably is Visual Studio Code. So you can use, again, whatever you want, but if you don't have Visual Studio Code, make sure you download it. Download it for your system, for Mac, for Windows, for Linux, whatever it is. And once you download, you open it up, and we can start writing our first Deno file. Now, first thing I'm going to do is I'm going to just save, and let's just say on my desktop, I'm going to say deno.fornow.js. So this, I can now write some Deno code. So let's just say function, and by Deno code, it's, well, JavaScript. Function A returns 42. Completely useless function. And now we can just run A. Now, if we open up the terminal, now let's say new terminal, and you can select over here your default shell, but let's say we want to run this file, I can now say deno.js. So that doesn't work. Well, again, if we do deno-help, we'll see that the command is run a program given a file name or URL to the module. So again, let's clear here, try that again, do Deno run, and then say deno.js. Awesome. It looks like it's working because it's not returning anything. Let's just console log here just to make sure that this is working. Let's save, run it again, and there you go. We have our first Deno program running. And at the end of the day, because it's a JavaScript runtime, we can run JavaScript just like that. So now we have the environment for Deno. But one of the cool things with Deno is that it has TypeScript built in. So if I create a new file here, and let's say new file, and we'll call this deno2.ts, which is a TypeScript file. And now I say, let's say const a string is going to equal my name. And here we'll just say console.log a. If I save this and I do once again deno2.ts, whoa, did you see that? Deno compiles the file. That is, it compiled this TypeScript file and then converted it into JavaScript, essentially removing this part that made it a TypeScript file, and then ran the program. This is something you can't do in Node. I mean, with Node, you can definitely use TypeScript, but you have to install a bunch of things. You have to use npm, package.json. But with Deno, out of the box, I was able to use TypeScript. And as a matter of fact, this is a really cool feature of Deno, that they have TypeScript compiler built in. Remember this? When we talked about the Deno runtime, I told you that Node and Deno are both, well, JavaScript runtimes. And each one has some things that they add on to the V8 engine so that we have functionality outside of just reading JavaScript. And one of the things that Deno had was TypeScript compiler built in to Deno. So what happens is Deno checks your file and says, is this a TypeScript file? Yes, it is. Okay, then I have a built-in TypeScript compiler that I'm going to feed that file to. And that file gets put into the TypeScript compiler, and then it spits out JavaScript, and that gets given to the V8 engine. So I didn't have to install any external dependencies that I would have with Node. I didn't have to set up TypeScript. TypeScript is already set up for us with default configurations. Now, we'll get into TypeScript a lot later in the course, but I just wanted to show you how awesome this is, how easy it was for us to just run something out of the box. This is just scratching the surface of the power of Deno. But let's take a break, get excited, because we got a lot more to cover. All right, everybody, it's time to finally build our first Deno project. Now, it's going to be a silly, simple one. It's going to get us started so we can build some really nice applications later on in the course. Let's start off with something that I thought would be fun. I have my deno.js file. I have my terminal here. We're going to say if, let's create a variable here. We'll call it food, and food equals love. And what we'll do is we'll say if food equals love, in that case, we'll console.log, and let's use an emoji here because, well, why not? Let's use a little dinosaur emoji. And let's say Deno is born. Otherwise, let's just say that we have an egg. This is a very complicated program, as you can see. Let's get another emoji here. Let's copy and paste this. This egg needs some love. There you go. What a wonderful program. If we save this and run it, so let's do Deno run deno.js. Deno is born. If food doesn't equal love, and let's say hate, well, this egg needs some love, so we can't grow our baby dinosaur. Up until now, this is just JavaScript, right? I can copy this code and run it in the browser if I want to. Let's open up the developer tools. I go to console, copy and paste, and There you go. Nothing changes. This code runs. But remember, with Deno, we get a few extra benefits. Because it's a runtime, it doesn't just run JavaScript. We get some little tools on top of that. Kind of like on the browser, we have the window object. The window object allows us to have lots of little tools that we can use for the browser. For example, let's see, we have IndexedDB, which is a little database we can use on the browser. We have the navigator. What else do we have? If we go to, let's say, the Ds, we have the document. So this is the document object model that allows us to have, let's say, the body of the HTML. So these are all things that are non-JavaScript that we have. And just like that, Deno comes with its own, what we call API. That is, things that aren't JavaScript, they're more Deno land features, will come with this Deno namespace. And we'll talk a little bit more about this later, but the one I want us to try using is deno.args. And deno.args allow us to get an argument. So I can say Deno run, and then I can get the argument of whatever that run is. Let me show you. So instead of const food equals love, I'm just going to say deno.args and get the first item in the array. So the first item in the array at index of 0, I'm going to grab. So now if I do Deno run deno.js and I give it an argument here, let's say some gibberish here, and I run this, the code runs because deno.args food is now going to equal whatever I just gave it. So let's change our code back to love. Let's save. And if I run this again with love, now remember, if food equals love, Deno is born. Let's see. Hey, look at that. Deno is born. Very, very cool. So that's a Deno tool that I just got. And Node does this as well, right? If I go to the Node.js documentation, or let's just do Node.js args, Node has this as well. Let's see, where's args? There you go. Or argv in their case. So we get these extra features. Now, some of them have the Deno namespace and some of them don't, like set timeout. We'll talk about why that is a little bit later. Hint, hint, these are all browser-like APIs. But for now, we used deno.args to build our first kind of silly but kind of fun Deno application. Now, one thing you may have noticed here is, let's say I do Deno here, and I do dot. I don't really get any completion, any information, because my VS Code doesn't really know what Deno is, right? I mean, when I run Deno, it knows what Deno is, but VS Code doesn't care, doesn't really know what this is. So it doesn't give me any hints. So what I can do is actually install an extension. And if we search Deno here, and the very first one is this one, the just JavaScript one, which I believe, at least as I'm recording this video, is the official Deno plugin. Now I have this plugin installed. So if I go back to my deno.js, oh, look at that. I have a little bit of a different color here. And if I do Deno dot, check that out. Now I have auto-completion and hints so that I know what the Deno namespace has. So over here, look at that. I see that I have the args. I have a whole bunch of other things that are essentially what's over here in the API docs. And this Deno package does a few other things that we'll discuss later that allow us to write Deno code. And remember, Deno is just a runtime, not a programming language. But by having our Deno on our machine and this environment set up, we're now ready to rule the world with Deno. And this is the exciting part. You see, JavaScript initially was just for the browsers. We could run JavaScript on the browsers. But now with things like Node and Deno, JavaScript just becomes a general scripting language. That means we can do a whole lot of things, not just within the browser. It's not just about websites. If I wanted to, I could read files on my computer. I can run web servers with Deno. Just like all the other languages, like Python, like Ruby, like C++. As long as I have this runtime with me, I can write code and tell my machine what to do. And Deno has all these nice things that it adds for us on top of just writing JavaScript. And those are things that we're going to explore throughout the course, all the way until we get to build a real-life application. It's going to be a fun one. We're just scratching the surface, but I hope this gets you excited because this is just the beginning. I'll see you in the next one. Bye-bye. Okay, everybody, this is probably the most important video. Don't skip this. Take out your notebook, write down notes, because without this, you cannot be a successful programmer. Get ready for this. Is it Deno or Deno? The answer, it's pronounced Deno. And here's the proof.
Yeah, so we're going to talk about Deno. We decided before this, there's a controversy over the pronunciation of this project. For some reason, I've always been calling it Deno, but there's Reno, and Deno is why it's a dinosaur logo. Anyway, we're going to talk about it.
There you go. From the creator himself, this is proof it's pronounced Deno. Okay, this was a bit of a silly video, but now we know. Let's move on to learning more about Deno. Welcome back. So we've been talking about the Deno runtime for a while. And I know we want to get to coding, we want to build some applications. But the thing is, once you learn the internals, you can do a lot of neat things. You can start looking at Deno source code. You can start reading up on issues and pull requests and actually understand what is happening behind the scenes. Because Deno is fairly new, there's going to be a lot of changes that are going to happen. But the runtime itself and how it works most likely won't change that much. So by knowing these fundamentals, these pillars, you're going to be able to adapt to changes very quickly. So up until now, we've understand this idea of runtime, a place to run JavaScript. And we know that Deno, this runtime, allows us to use the V8 engine, which they've taken essentially from Google Chrome, to feed it JavaScript files. Now we also know that it has a built-in TypeScript compiler. So they've included this so that we can write TypeScript as well as JavaScript and still have them run. Now, the way Deno works is that if you wrote in TypeScript, that is with a .ts file, it will compile it and convert that into JavaScript. But if you just write a simple JavaScript file, then it will just ignore this compilation process. It won't run the TypeScript compiler and instead just feeds it directly to the V8 engine. Either way, both of these files in Deno get sent to the V8 engine. Now the V8 engine knows how to read JavaScript, right? It's able to communicate with the machine and tell the machine what to do based on the script that you gave it. But what else is there? There's got to be more, right? And yes, there is. You see, Deno at the end of the day is creating this process on your computer or any computer. When you run Deno, a process is being started. A process is simply a program in execution. When you open a desktop application, it creates a process. When you open Google Chrome, it creates a process. And what that is essentially a sandbox, a place that the computer says, hey, here's some memory, play within this box, and you can run a program. Now, something like a web browser, let's say Google Chrome, has similar things. It has the V8 engine, but then it also has things like web APIs. And just like that with Deno, we have all these tools that we can use. Now, this is the interesting part because Deno has this thing called Rusty V8. And Rusty V8 is, well, a program written by the Deno people. Well, to do what? Remember how we learned how Deno is written in Rust? Well, this is the part that gets exciting. Because the Rusty V8 layer that they add allows this V8 engine and the code that we write to communicate with the Rust code that Deno has. So let's think about this for a second. First off, Node is written using C and C++, but the Deno creators decided to use Rust because Rust is a fairly new multi-paradigm language and it has really good safety, especially when it comes to memory. It's a growing programming language that allows you to essentially code things in a way that are safer most of the times than C and C++. And it's also extremely performant. So what the Deno runtime is able to do is to use this Rusty V8 to say, hey, V8 engine, if there's ever anything I need you to do outside of just JavaScript, please send it over to this Rust, what we call isolate, or this Rust code that we already have. For example, on Deno, you can access files. You can run commands like set timeout. When that happens, when things are outside of just JavaScript, Rusty V8 takes that and sends it over to the Rust world. You can almost think of as the front end of Deno being JavaScript or TypeScript and the back end being Rust. Now, if we actually take a look and we go to the Deno GitHub repo, there's a place that says core. And in this folder, when we take a look and we go into core.js, we actually see this binding layer. Now, we don't need to read through the entire code, but if we check over here, we see that we have deno.core and it has within core receive and send. Now, you can see here that's available on start due to bindings. This is essentially what I'm showing in the diagram. This deno.core is the main API that allows us to communicate between the JavaScript world and the Rust world. So we can do deno.core.send to send information to the Rust world, and we can do deno.core.receive to receive messages from the Rust world. That way, we can do some things really, really fast, really performant, using a language like Rust, so that Deno is essentially a full-featured runtime. We can access our files, we can send emails, we can create servers, all type of things. And in the Rust world, these operations that we do on our system, on the computer, are called ops. Just like syscalls, they're just operations we need to do on the machine to perform a task. Now, here's the final part. And this, as you'll see, is how web browsers work and how Node works as well. We need to have now asynchronous I/O. What does that mean? Well, let's pretend that we make a request, a set timeout request. In order for us to be able to run multiple things, multiple operations at the same time in the background, we need something called an event loop, a way for us to run events in the background. And this is where the Tokyo library comes in. The Tokyo library is a Rust project, Rust library, that allows us to use what we call a thread pool and workers to essentially do work for us. So what happens is when we run our JavaScript code, if we ever use something that isn't strictly JavaScript, and when I say that, what I mean is if we go to the Deno docs, we look at the Deno API, anytime we run anything with the Deno namespace or even something like add event listener or set timeout. All of these are APIs that allow us to talk to the Rust backend that the Deno developers created. And then once the worker, using Tokyo, finishes a task, it then sends it back all the way into our Rusty V8 that allows us to communicate with the engine, and then returns it back into our JavaScript world. And although this may look confusing, like I said, this is how web browsers work. This is how Node works. Don't trust me? Let's have a look. This is the diagram for the Node system. It looks quite similar to our Deno architecture, right? We have our application, so that is our JavaScript file, and that gets sent into the V8 engine. The Node ecosystem has what we call the Node.js bindings. So that's kind of like the Rusty V8. It's written in C and C++, just like Rusty V8 is written in C++, because V8 is written in C++. So it communicates with the V8 engine, and anytime there's operations in the V8 engine that aren't JavaScript, it sends it to something called the libuv. So libuv in this case is what Tokyo is. It's an asynchronous I/O library that allows us to do these operations using a non-blocking event loop. And you can see here that it even has worker threads, ways for us to work with the file system, with the network, with different processes. So when Ryan Dahl created Node, he wrote this part, this libuv, and these Node.js bindings. Just like in Deno, they used the Rusty V8, and instead of reusing libuv, they used Tokyo. Why did they do that? Well, we can actually hear it from the creator, Ryan Dahl himself. You can see in the Deno issue, somebody asked, why did you choose Tokyo instead of libuv? And congratulations, that makes sense to you now. You understand why that question was asked. I mean, they both do the same thing. To which Ryan says, Tokyo is a Rust module. Libuv is C and would necessitate building a bridge to run futures. Now, don't worry about futures. Those are essentially promises in the Rust world. But we now understand because they wanted to write Deno in Rust, they wanted to use Tokyo because it's already a well-maintained Rust module instead of creating bindings that attach libuv to Rust. And by the way, this idea of workers, which we're going to talk about in the appendix section, seems overwhelming, but this is what browsers do as well. Browsers have web workers. That's essentially what worker threads are in the context of Tokyo. And libuv in Node had workers as well. But the cool thing is that if we go back to the Deno documentation, to Denoland, and we go to the manual, understand this fully. Deno is a JavaScript TypeScript runtime with secure defaults and a great developer experience. It's built on V8, Rust, and Tokyo. That's right. The building blocks of Deno are Rust, Tokyo, and V8. And this should make sense now. Now, I know we really got into the weeds here. Again, I wanted to make sure that we understood what we're working with. As a Deno programmer, you're never going to really touch Rust code or Tokyo or V8. These are just tools that are allowing Deno to do things really, really well, really, really fast. As the Rust programming language that is backed by Mozilla gets more and more features, gets more and more advanced, more performant, Deno gets its benefit. Same with the Tokyo module, and same with the V8 engine. As the Google team improves the V8 engine and improves the performance of this engine, Deno gets the benefits. And because these are all modern, these are all really nice tools, and because Deno was built with these tools in mind, it allows it to have what I think a really promising future. Now that we understand the internals of Deno, which I think is really exciting because Deno is fairly new, it's well built, we're able to understand the internals of it without all the complication that I think comes with Node. And there's a sense of power and understanding that comes from it, right? Knowing how our tools work will make us better programmers. Now that we know the internals and what Deno is actually doing underneath the hood, I'm going to show you something really exciting. Well, I think it's exciting. And after this video, I want you to play around and experiment as well. Because I think having this knowledge, although it might not be useful when building, let's say, servers, it's good because it lays the foundation of understanding what the tools that we are using are doing. So what am I talking about here? Well, there's a really interesting tool that Deno give us. Part of their API is something called metrics. And you can see over here, it pops up. Now metrics let's run it and see what happens. I'm going to run our code. And that was it. Well, because we have to console log it. So let's do console.log Deno metrics. If I save and run this again, oops, let me remove the semicolon, try that again. There we go. Look at that. Deno metrics gives us an object with some interesting information. Now, there's actually a prettier way to display this. You just do console.table. And if I save this and run it again, look at that. I have everything in a table. Now, the interesting thing here is, well, if we go over metrics, it says, receive metrics from the privilege side of Deno. This is primarily used in the development of Deno ops, also called bindings, are the go-between Deno JavaScript and Deno Rust. And we've learned about these, right? Deno.metrics essentially tells us about the communication between the JavaScript side and the Rust side, those bindings. And look at this. It gives us information that there was one operation that was dispatched. There's one synchronous dispatch operation. There were this many bytes received, this many bytes sent. That's really, really cool. Well, I think it's cool, but now that we know this, and we know that there's these bindings that Deno communicates with the Rust side of the project because Deno was built with Rust, let's try something. What happens? Right now, we don't have any asynchronous code, so let's use Tokyo for the event loop. Let's do a set timeout. And set timeout isn't part of the JavaScript language, right? The JavaScript engine, the V8 engine, doesn't understand set timeout. That's actually an API, a Deno API. So Deno implements that. For example, if I go to the API docs and I go to, where is it? Set timeout. Oh, there you go. Set timeout is part of Deno. Just like the browser has the browser API set timeout, well, Deno has it the same with Node. So if we now go over here and do an asynchronous call, because we know set timeout creates an asynchronous event loop, let's just say in here, console.log check. And let's do that after 1 second. Let me make this a little bit smaller so we can see our code. That's it. So we added a set timeout, I save, and I now run this. Let's look at the metrics. We have 2 operations dispatched now, one synchronous and one asynchronous. How cool is that? So compared to last time, we have bytes set control that are a little bit higher, but we also have more dispatched calls, ops dispatch calls. One is async. But you see here that we've only completed one synchronous call, but we haven't completed any asynchronous code. Think about it. Why is that? Well, because we're calling Deno metrics right here, while the set timeout gets sent over to and triggers the event loop in Tokyo, console.table has already run. So in that case, if I move this over here, we should get it after the asynchronous code ends, because this part says, hey, run a timeout, run the event loop, and if in 1 second, run this block of code. So it's going to run this after the asynchronous code returns, the set timeout returns, and we're back in JavaScript land. So if I run this, let me save, and I run this. Let's have a look. Hey, look at that. Ops completed. So we've completed our asynchronous operation, and it's returned from the Rust land. So you can see over here, there's a bit of a difference here. Now, these are just small, minor details. Most of the time, you're never going to run this command. You don't really need to know how the bindings work, unless you're doing something really, really low level. But I think this is cool. We're understanding the internals of Deno. We understand what this communication is doing. And having just that power, that knowledge, really helps us become better programmers, because we have now a pillar to stand on. We're not just writing magic. We understand what happens when we call the Deno. What happens when we call set timeout? And why Deno, why Node is called a JavaScript runtime now. Now go ahead, go play around with Deno.metrics. Have fun, and I'll see you in the next lesson. Let's do an exercise to really test your understanding here. If I asked you, whenever you write code and that JavaScript file or TypeScript file gets given to Deno, when do we run the Rust code that Deno comes with? Think about it. When does that happen? Ready for the answer? The answer is whenever we call Deno, the Deno namespace that we saw in the API, or the window namespace. What do I mean by that? Well, if you go to the runtime API, that's when we run our Rust code. This Deno.all these tools or functions are running when we run them in our code, when we use them, are going to the Rust land. Also, the window namespace. We're going to talk about this window namespace as well, but things like atop, beta, add event listener, clear interval, dispatch event, these are all part of the window object. For example, if I go to my Deno code, let's say at the end here, we'll do console.log window. If I run this, let's save and run Deno like this, we see that there is a window object that gives us, look at this, just like we have in the API, the clear interval, the clear timeout. We even have fetch. All these things come built in. Now, this isn't JavaScript. Write file sync, for example, to write files, or test aren't part of JavaScript, but they are part of Deno. These extra tools, these extra APIs that we can use in Rustland. And check it out. In the core, we even have the receive and send to send those messages to the Rust world. Now, this is really interesting because things like fetch don't actually exist when it comes to Node. Let me show you. You see, in Node, we don't have a window object. And we'll talk about this a lot more in upcoming videos. But I have here a Node.js file, and I'm just going to say console.log global. And global is the Node version of window. So if I console log this, let's save this file, and I'm going to say Node, which I already have installed on my computer, and I'm going to run the Node.js file. You see here that I have global that has the same thing. It has clear timeout. It has set immediate, set interval, or clear interval, set interval, but there's no fetch. Deno strives to have what we call a browser compatible API, a way for us to use the window object like we do with browsers. And again, we'll talk more about this a lot, but one of the big issues with Node is that it's missing that compatibility with the browser. For example, big issues when we go to the Node project is to implement window.fetch into the core. Because, well, a lot of people have to download the Node fetch npm module to be able to use the fetch keyword in Node. And as you can see, a lot of people want this feature, but because of some legacy things, which you can read about, you don't have that out of the box with Node. How cool is that? Now that you understand the architecture of Deno, we can move on. I'll see you in the next one.